Hello students. So yet another EPP we have, and this is of amazing Heisenberg's uncertainty principle. So here are 4 questions. Let's read and attempt them. The first question says, which wave pattern corresponds to the greatest uncertainty in momentum? See, all of them are wave patterns, and this is the wave spread given. We know one thing from Heisenberg's principle, that delta x and delta p are minimum, they are equal to h upon 4 pi, right? So as you can see, wave is spread in space. So the wave which has minimum spread in space will have the maximum uncertainty in momentum. That means there will be so many wavelength present in that. So many uncertain wavelengths. You can clearly see it is quite certain wavelength. That means we know the wavelength is, and it is also spread to the maximum extent. It is going beyond, right? So I think this is a very high spread in delta x, so very low uncertainty in momentum. So as you can see, this is now narrow. It has a finite range, but still not the minimum. So this delta x is quite big. Delta x again contracted, and I think this is our guess. This is the minimum delta x. So minimum delta x will correspond to maximum delta p. So this will have delta p maximum. That means there are so many wavelengths present in this that we are not able to measure. So that's our answer. Greatest uncertainty in momentum will go to the narrowest uncertainty in position. Wonderful. Now let's come to the second. If the minimum uncertainties in position and momentum are x and y, then Planck's constant is given by. Oh, that's good. We know that delta x and delta p are minimum equal to h upon 4 pi. This has been given equal to x, and this has been given equal to y. So I think if you cross multiply 4 pi to this side, so you will get Planck's constant equal to 4 pi into xy. So there's one option waiting for us. Actually, Planck's constant is a constant, but this question wants us to express it in x and y terms. That's also nice. Now let's some calculative questions. Determine the minimum uncertainty in the position of a particle of mass equal to 0.5 picograms. Pico, you know, 10 to the power minus 12. With 1% uncertainty in speed, which is expressed at past 6 meter per second. That means question is very clear. Velocity is given to be 10 to the power 6 meter per second, and delta V is 1% of that. So 1% of 10 to the power 6 will be equal to surely 10 to the power 4. Mass is clearly 10 to the power 0.5. We can write 0.5 as half picograms. Picograms is 10 to the power minus 12 grams, but we need to convert in kilograms for SI system. So there is the answer. Now you go to the formula expression of Heisenberg principle. You get delta x will be equal to minimum uncertainty h upon 4 pi will already be there into delta p. Now delta p will be just mass into delta v. You see, uncertainty in momentum will come from uncertainty in velocity, not on mass. Now if you express all the quantities that are given here, so we'll get 0.53, then 4 pi is already adjusted, then for mass we write half, and rest of the thing are 10 to the power powers. So you can see 10 to the power minus 34 is already there. Then mass you have 10 to the power minus 15, and delta V you have 10 to the power plus 4. So you just see, if you take 15 plus 4, this will be minus 11, and this will go to the top. To cancel this out, it will be minus 23 if you subtract 11 from there, and 1 by 2 will go to 0.53. So my answer coming out to be this 1.06, and then you subtract 11 from minus 34, so you'll get how much? You'll get minus 23. So none of the answer is matching basically, so that's the safest option D. That's why in today's examination none of the above option is always kept, so that question does not get bonus. Here we got the value, but it was not present, unfortunately. So now let's come to this. Which of the following feature of Bohr model, we all know Bohr model is, was not acceptable to the believers of Heisenberg's uncertainty principle? You see, Heisenberg principle said you cannot measure position and momentum of a particle simultaneously, right? So wherever there is position and momentum thing, you have to avoid it. So accurate orbit radius. See, this was not acceptable, I think. The A is there. Now, precise mass of electron. Heisenberg does not have anything to do with mass. Mass can be clearly well defined. Fixed energy. See, energy conservation principle is a very, very fundamental principle in science. So B and C are not going to be the option. All of the above is also not going to be there. It is the accuracy of the Bohr orbit that was the problematic to Heisenberg's principle. Thank you.